Viscosity we had defined, it is nothing but the property of the fluid by virtue of which the fluid offers resistance to deformation under the action of shear stress. Okay, so we had seen this definition in detail. Okay, after that we had seen Newton's law of viscosity, which states shear stress is directly proportional to rate of shear strain or simply velocity gradient. Okay, so mathematically tau is directly proportional to du by dy, or tau equals to mu du by dy. Okay, here this term du by dy, it is called as rate of shear strain, or simply rate of shear deformation, or simply shear velocity gradient. Okay, so mathematically tau equals to mu du by di. Here mu is nothing but it is a property of the fluid that is called as absolute viscosity. Okay, after that we had seen the unit for absolute viscosity is Newton second per meter square in SI system, and dyne second per centimeter square in CGS system, as well as another industrial unit is poise, where 1 poise equals to 1 poise equals to 0.1 Newton second per meter square, or 1 Newton second per meter square equals to 10 poise. After that, we had also seen the dimensions for viscosity. So dimension of absolute viscosity is m1 l minus 1 t minus 1. Okay, so I think we had covered all this. After that, we had seen what is the effect of temperature on viscosity of the fluid. So in case of liquid, as the temperature increases, the viscosity decreases. Why? Because in case of liquid, the liquid are held together by strong cohesive forces. So whenever the temperature increases, this heat is absorbed by molecules. Molecules expand. So as the molecule expands, the center to center distance increases, and as the center to center distance increases, cohesive force decreases. So as cohesive force decreases, viscosity decreases. Okay, this is the reason why ऑयल का विस्कोसिटी आप हीट करते हो कुकिंग ऑयल का तो वो रिड्यूस होता है. ओके, वाइस वर्सा इन केस ऑफ गैसेस, गैसेस में क्या होता है कि विस्कोसिटी इज ड्यू टू कोलिजन्स बिटवीन द नंबर ऑफ गैसेस मॉलिक्यूल्स, and because of that molecular momentum exchange take place. So as the viscosity increases, heat is absorbed by gaseous molecules. Gaseous molecules का internal energy increase होता है, so they start to move at higher rate. So जब वो ज़्यादा velocity से move होते हैं तो उनका ज़्यादा collision होता है. ज़्यादा collision होने से molecular momentum exchange increase होता है, and thus viscosity of gases increases with increase in temperature. Okay. After that, we had also seen this entire chart, which gives the classification of fluid based on Newton's law of viscosity. So Newtonian fluid are the fluid which obeys Newton's law of viscosity, and for them, uh, the curve is a straight line, making an index viscosity index n equals to 1. Then non-Newtonian fluids. So non-Newtonian fluids are the fluid which does not obey Newton's law of viscosity. So for them, Newton's law of viscosity is modified to tau equals to mu du by dy to the power n. Here, if n is greater than 1, then fluid are called as dilatant. Sorry, if n is less than 1, so the fluid are called as dilatant. If n is greater than 1, यहाँ पे mistake है, okay, then they are called as pseudoplastics. Okay. After that, next is thixotropic, being an fluid or plastic fluid. So there are some fluids which are semi-solid, but on the application of shear stress, they start to flow. For example, toothpaste. Okay, so such type of fluids are called as uh, ideal plastic fluid if they obey Newton's law of viscosity. So for ideal plastic fluid, tau equals to yield stress. Okay, some yield stress. If you are applying stress less than yield stress, they are solid, and if you apply yield stress, they start to flow. Okay, so tau equals to tau yield plus mu du by dy. Okay, an example where toothpaste, oil paint, jellies, etc. Then next is thixotropy. So these are the fluids which are semi-solid, but on the application of yield stress they flow, but they does not obey Newton's law of viscosity. For them, tau equals to tau yield plus mu du by dy to the power n. Okay, an example is printer, ink, lipstick, etc. Okay. After that, we had seen the rheology. Rheology is nothing but it is a branch of science which deals with the study of liquids. Okay, basically thixotropic liquid under different stress conditions. Okay, in simple words, rheology, it basically deals with pharmaceutical industries. Okay, and basically most of the creams, gels, paste, ointments, okay, इनका जो स्टडी किया जाता है, so that all comes under the branch of rheology. बेसिकली रियोलॉजी ये फार्मेसी से रिलेटेड सब्जेक्ट है, बट वहाँ पे भी फ्लूइड मैकेनिक्स का नॉलेज लगता है. Okay. After that we had seen fluid kinematic, sorry, kinematic viscosity. So kinematic viscosity is simply defined as the ratio of absolute viscosity to mass density of the fluid. It is denoted by Greek symbol nu. So nu equals to viscosity upon mass density. So nu equals to mu by rho. Okay. After that we had seen the unit is meter square per second in SI system, centimeter square per second in CGS system, and industrial unit is stoke, where one stoke equals to 1 centimeter square per second or 10 power minus 4 meter square per second. Okay. After that, dimension of kinematic viscosity is m0 L2 T minus 1. After that, I think we had seen two problems in last lecture. So today we will going to continue with our problems. Okay. So write down. Calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 0.8 meter by 0.8 meter and an inclined plane with an angle of 30 degree as shown in figure. The weight of the square plate is 300 Newton and it slides down the inclined plane with a uniform velocity of 0.3 meter per second. The thickness of the oil film is 1.5 mm. Okay, so you can see in the given problem, area is 0.8 by 0.8, so 0.64 meter square. Theta is 30 degree, W is 300 Newton, U is 0.3 meter per second, and thickness, which is nothing but dy, so 1.5 mm, so 1.5 into 10 power minus 3 meter. Okay, so you can see this is a given problem. So this weight is acting 300 Newton in downward direction. Thickness is 1.5 mm, U is 0.3 meter per second, and in between these two plates, oil is filled of viscosity mu, which we are supposed to calculate. Okay, let the viscosity of the fluid between the plate and inclined plane is mu. Okay, so the component of the weight along the plane, so that will be W cos 60. Okay, sorry, that angle will be 90 minus 10. Okay. Wait, we will see the simple geometry. Okay, this angle is 30 degree. This angle will be 60 degree. If this angle is 60, so opposite this angle is also 60 degree. Okay, this is parallel. These two surfaces are parallel. So if this angle is 60 degree, this angle is also 60 degree. Okay, so remember ये 30 रहा, तो ये एंगल जो होता है 90 minus 30 होता है. Okay, so that angle is 60 degree. So component of weight along the plane, so it is W cos 60. Okay, so it is 300 cos 60, so it is 150 Newton. So basically shear force acting on the bottom of the plate, it will be 150 Newton. Okay, so हमें tau पता है, हमें area पता है, so we can calculate shear stress. So shear stress is nothing but force upon area, so it is 150 divided by 0.64. Okay, so on solving this, you can find out shear stress. Now we know tau equals to mu du by dy. Okay, यहाँ पे du is nothing but change in velocity. अभी ऊपर के अब जो प्लेट है वो 0.3 से मूव हो रहा है, तो अपर लेयर or the layer of the fluid in contact with the upper plate, it is also moving with 0.3 meter per second. दूसरा जो surface है, it is a stationary surface, so the layer of fluid in contact with the lower surface, its velocity is 0. So change in velocity will be 0.3 minus 0, so 0.3 meter per second. Okay, similarly dy is thickness. Okay, so it is 1.5 into 10 power minus 3 meter. So we put the value, so we will have tau is 150 upon 0.64 equals to mu into 0.3 upon 1.5 into 10 power minus 3. Okay, So cross multiply this 1.5 into 10 power minus 3 and divide 0.3. So you will get the value of absolute viscosity mu. Okay. So everyone, do the calculation and tell me the answer of absolute viscosity mu. Yes, calci पे quickly solve करो. 150 multiplied by 1.5 multiplied by 10 power minus 3 divided by 0.64 into 0.3. So answer is 1.17 Newton second per meter square. 1.17 Newton second per meter square. Yeah, very good. Okay, so let's see the next problem. If the velocity distribution over the plate is given by u equals to 2 by 3y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate. Determine the shear stress at y equals to 0 and y equals to 0.15 meter. Take dynamic viscosity of the fluid. Take dynamic viscosity of the fluid as 8.63 poise. Okay, what is given in this problem? In this problem, there are two plates. Okay, this is lower plate and this is upper plate. Lower plate is fixed, while upper plate is moving with some velocity, and actually this direction is y direction. Okay, now the velocity is increasing in y direction following the relation u equals to 2 by 3y minus y square. Okay, here as the distance y increases, so the velocity is also increasing following this relation. Okay, here what is given, we are supposed to calculate whatever the velocity at y equals to 0. Y equals to 0 पे कितना shear stress रहेगा, and y equals to, suppose this is 0.15 meter, at y equals to 0.15 meter. Okay, equals to 0.15 meter. So what is the shear stress? Tau. Okay, इतना हमें निकालना है. After that, dynamic viscosity mu is equal to 8.63 poise. Now remember, 1 poise is equal to 1 by 10 न्यूटन सेकेंड पर मीटर स्क्वायर. ओके, ये रिलेशन आपको याद रहना चाहिए. ओके, बिकॉज प्रॉब्लम में नॉर्मली पॉइस में दिया जाता है. इवन इन इंडस्ट्री विस्कोसिटी इज मेंशन इन पॉइस. ओके, तो आपको पॉइस का कन्वर्जन आना चाहिए. सो 1 पॉइस इक्वल्स टू 1 by 10 न्यूटन सेकेंड पर मीटर स्क्वायर. ओके, so given is u equals to 2 by 3y minus y square. Okay, therefore first of all we will calculate du by dy. If u equals to 2 by 3y minus y square, so du by dy, okay, it will be 2 by 3 into differentiation of y. Differentiation of y is 1, so 2 by 3 into 1 minus y square differentiation 2y, which is 2 by 3 minus 2y. This is du by dy. Okay, now du by dy at y equals to 0. Okay, so at y equals to 0, y का वैल्यू 0 पुट कर दो. So it is 2 by 3 minus 2 into 0. So simply 2 by 3, 0.667. Okay, so du by dy at y equals to 0 is 0.667. So we can apply this value in Newton's law of viscosity. Okay, similarly du by dy at y equals to 0.15. So at y equals to 0.15, it is 2 by 3 minus 2 into y का value है 0.15. So 2 by 3, which is 0.667 minus 2 into 0.15, so minus 0.3. So it is 0.367. Okay, this is the du by dy at y equals to 0, du by dy at y equals to 0.15. Okay, so also value of absolute viscosity mu is 8.63 poise. So it's 8.63 divided by 10, so 0.86 is 0.863 Newton second per meter square. Okay, so once we know this value, so we know shear stress is given by tau equals to mu du by dy. So at y equals to 0, okay, shear stress tau 0, tau at y equals to 0 equals to mu to du by dy at y equals to 0. So it is simply 0.863 multiply by 0.667. Okay, mu का value 0.663 and du by dy y equals to 0.667. So take the product. So it is 0.5756 Newton per meter square. Okay, shear stress. After that, shear stress at y equals to 0.15. So we know at y equals to 0.15, tau 0.15 is equal to mu du by dy at y equals to 0.15. Okay, so यहाँ पे put करो mu is 0.863 and du by dy is 0.367. Okay, so just take the product 0.863 into 0.367, so it is 0.3167 Newton per meter square. The space between two square flat parallel plates is filled with oil. Each side of the plate is 60 centimeter. The thickness of the oil film is 12.5 mm. The upper plate which moves at 2.5 meter per second requires a force of 98.1 Newton to maintain the speed. Determine the dynamic viscosity of the oil in poise. Determine the dynamic viscosity of the oil in poise and the kinematic viscosity of oil in Stokes. If the specific gravity of the oil is 0.95. Okay. Now what is, quickly we will see what is given in this problem. So there are two square parallel plates. Okay, this is plate 1, this is plate 2. Okay, in between this oil is filled. So in between them oil is present. Each side of the plate is 60 centimeter. Okay, so basically area of both the plates. Okay, area of the square is side square, so it is 0.6, 60 centimeters, 0.6 meter. It is 0.6 meter by 0.6 meter. Okay, so it is 0.36 meter square. And thickness of the oil film, so this T is given. Okay, so this T is nothing but total dy. So dy is 12.5 mm, so 12.5 into 10 power minus 3 meter. Okay, apart that, the upper plate is moving at a velocity of 2.5 meter per second. Okay, so this u is 12.5 2.5 meter per second. Okay, while lower plate is stationary, so u at lower plate is stationary because it is fixed. Okay, and the force required to maintain this speed of 2.5 meter per second, so this force is 98.1 Newton. Okay, so this force is 98.1 Newton. So we are supposed to calculate the dynamic viscosity and kinematic viscosity. Okay, so this is our given problem. So area of the plate is 0.6 by 0.6, so 0.36 meter square. Dy is 12.5 mm, so 12.5 into 10 power minus 3 meter, and u is 2.5 meter per second. Okay, therefore change in velocity is u minus 0. So it is 2.5 minus 0. So du is 2.5 meter per second and force is 98.1 Newton. So first of all, we will calculate the shear stress. So we know shear stress equals to shear force upon area. So it is F upon A. So 98.1 divided by 0.36. Okay. So this will be the shear stress. Now this shear stress tau equals to mu du by dy. Okay. So put all the values. Tau का value है 98.1 upon 0.36. du का value है 2.5. dy का value है 12.5 into 10 power minus 3. Okay, so put all the values. So our task is to calculate the dynamic viscosity mu. So we are getting the answer 1.3635 Newton second per meter square. Now remember, they haven't asked us the answer in Newton second per meter square. So remember the conversion, 1 Newton second per meter square equals to 10 poise. So you will multiply now with 10. So it is 13.635 or 13.6. Okay. Now, next thing is calculate the kinematic viscosity. Okay. So now we will calculate kinematic viscosity. So we know kinematic viscosity, it is nothing but unknown. So we will denote by mu. After that, mass density of the given fluid, it is S into 1000. So 0.95 into 1000. So 950 kg per meter cube. After that, as per the definition, kinematic viscosity, it is the ratio of absolute viscosity to mass density. Okay. So it is 1.3635 divided by 950. Okay. So it is 1.3635 divided by 950. You can solve this on calci. So you will finally get 0.001435 meter square per second. It is 14.35 stokes. Okay. So it is 0.001435 into 10 power 4 centimeter square per second or stoke. So the dynamic viscosity of an oil used for lubrication between a shaft and sleeve is 6 poise. The shaft is of diameter 0.4 meter and rotates at 190 rpm. Calculate the power lost in the bearing. Calculate the power lost in the bearing for a sleeve length of 90 mm. Thickness of the oil film is 1.5 mm. Given, so given is mu equals to 6.0.6 Newton second per meter square. Diameter is 0.4 meter. Speed is 190 rpm. Length of the sleeve is 90 mm, so 90 to 10 power minus 3 meter. And thickness T is 1.5 mm. 1.5 into 10 power minus 3. Okay, so this will be the case of shaft and sleeve. Okay, so first of all, calculate the tangential velocity. U equals to pi d n upon 60. So quickly put the values. Pi into 0.4 into 90 into 10 power minus 3. Okay, so it is 3.98 meter per second. After that, now we know tau. So tau equals to mu du by dy. Okay, so du is change in velocity, u minus 0, so 3.98. So put the values. So tau equals to 0.6 into 3.98 divided by 1.5 into 10 power minus 3. After that, we know shear force. So shear force is nothing but shear stress into area. So area is nothing but, in this case, pi dl. So pi into 0.4 into length is 90 into 10 power minus 3. Okay, so it is 1592 into pi into d into l. Okay, so 1592 into pi into 0.4 into 90 into 10 power minus 3. So it comes out to be 180.05 Newton. After that, we will calculate the torque. Okay, what is the torque on the shaft? So torque is nothing but whatever the force into radius. Okay, so radius is nothing but, diameter is 0.4, so radius will be 0.4 by 2 or d by 2. Okay, so torque is force into d by 2. So it is 180.05 into 0.4 divided by 2. So it is 36.01 Newton meter. After that, power loss. So we know power loss is nothing but, it is torque into omega. Okay, or 2 pi nt by 60. Okay, torque into omega. Omega is nothing but angular velocity, which is 2 pi n upon 60. So simply power lost is nothing but 2 pi nt upon 60. Is 2 pi nt by 60 in watt, or 2 pi nt upon 60,000 in kilowatt. So 2 pi into 190 into 36.01 divided by 60. Okay, so on solving this, it comes out to be 2 pi into 190 into 36.01 divided by 60. So 716.48 watt, or in kilowatt, it is 0.716 kilowatt. Okay, so we will stop here today. Okay, there are 1-2 more problems, and then we will see the remaining properties, that is surface tension, capillarity, and numericals on them.